Hey, welcome to this lesson on simplifying radicals. We have a fraction here called, or I'm sorry, not a fraction, we have a square root of 28. So there are two ways to do this. I'm going to show you the long drawn out process, and I'm going to show you the method that I use, and I hope that you learn to use. That way you can get your simplifications done a lot sooner. Square root of 28 breaks down into square root of 7 times 4, and then square root of 7 times 2 times 2. And therefore, we cannot break 7, 2, or 2 down. So what you're looking at is, you see these two? If we have those two 2's, isn't that the square root of 7 times the square root of 2 squared? And we should know the square root of 2 squared is kind of like the square root of 4. But we should know that the square root and squaring a number cancel each other out, leaving us with just 2. So therefore we'll write 2 square root of 7. The number under the radical always goes second, and the number without a square root symbol goes first. The method that I would like you to use is to have these numbers memorized. 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. These are going to be the perfect squares. We know this is 2 squared, 3 squared, 4 squared, 5 squared, and so forth. You get the idea. If you have those memorized, which perfect square goes into 28? Square root of 4 does. So we're going to break down the square root of 4 times the square root of 7 to be this. And the square root of 4 is 2 times the square root of 7. Now, you have to have that memorized, these perfect squares. And then even sometimes that doesn't always work, because sometimes you work with numbers that you're not used to, you're not used to as being a perfect square. So you should be able to do it both ways, this method and this method. I prefer you use the method on the right because it goes by a lot faster. But if you can't use the method on the right, then you need to be able to break it down like the method on the left. Square root of 54. Square root of 54. Well, square root of 54 breaks down into the square root of 6 times the square root of 9. Well, 9 is a good one for us, right? That's a perfect square. What's the square root of 9? 3. And what's the square root of 6? There is no perfect square that goes into the square root of 6. 4 does not go into 6, and 9 is too large. The other method you could have used was the square root of 27. Square root of 27, let me do it this way, times 2, that's 54. And the square root of 27 breaks down into 9 times 3. And then there's the 2. And the square root of 9 breaks down into 3 times 3. And then we drop down this 3 and this 2. Now, just like in the first one, you see 2 3's here. That's going to be square root of 9. And then there's no other pairs of numbers. This 3 does not have another 3 in there, and this 2 does not have another 2 in there. So we're looking for pairs. So 3 times 2 becomes 6. And then once again, we're back to where we were here. Square root of 9 is 3, square root of 6. Alrighty, 72. Try to figure out which perfect square goes into 72 and see if you can split it up. We could go 36 times 2, which that's a good one. 36 times 2. We could go 9 times 8, which that's a good one too. Perfect square, and 36 was a perfect square. And you might notice how I'm writing these differently. How I just have one radical here on the left side, and then here I have 2 radicals. Well, it's the same thing. When you're multiplying, you're able to split it up from either 1 radical or split it up into 2 radicals. It's okay to do it that way. So don't get confused by my 1 radical and 2 radical. Let me just be consistent here on this one. And what's another one? 12. The square root of 12 times 6. So here we have 36 times 2, which is 72. Here we have 9 times 8, which is 72. And we also have 12 times 6, which is 72. Which one's the best one? Well, the largest square root is probably going to be the best one, because what's the square root of 36? Square root of 36 is 6. And the square root of 2, well, 2 does not have another 2 in there with it. 6 times the square root of 2. Now, how about this one here? Well, we know the square root of 9 is 3. And what about 8? We could put the square root of 8. But remember, 8 is not a perfect square, so we can't break it down and get rid of the radical with it. So if we're looking here, these two don't match up. And I know the one on the left, 6 square root of 2, is the correct answer. So what's going on there? Well, there's a perfect square that goes into 8. So there's my 3. What's the perfect square that goes into 8? 4. Drop the 3 down. What's the square root of 4? 2. And when it comes out without the radical, it's multiplication in there. And then the square root of 2, well, just stays the square root of 2. 6 times the square root of 2. Okay. Alrighty. And how about the one on the right? Square root of 12 times the square root of 6. Square root of 12 breaks down into 3 times 4. So that's 12. What's 6 break down into? 3 times 2. Now what does, here's the 3. Now what does 4 break down into? 2 times 2. And then here's the second 3, and then the last 2. Now remember, if we're going to pull these outside, we have to pull these out in pairs. Okay? Right there. That's a pair of 2s. So they come outside without the radical. Right here. It's a pair of 3s. Comes outside without the radical. And this 2 right here is the only 2 without a pair with it. So it stays inside. It stays underneath the radical. 2 times 3, 6 times the square root of 2. And you notice now how we have the same answer for every single one. Simplify. The square root of 10 times the square root of 16. Okay? This equals the square root of 160. And then you're going to simplify from there. But you could simplify beforehand. How about the square root of 16? What is it? That would be 4. And then we have the square root of 10. We know the square root of 10, if we look here, the square root of 10 just breaks down into 2 times 5. and there are no pairs between 2 and 5, and those are the prime numbers there, you cannot simplify the square root of 10. So that's the reason why it stays square root of 10. So we put the 4 first, and then the square root of 10 comes second. Preferably, you don't want to work with large numbers because sometimes you mess up and you're looking there, oh, the square root of 160, 169 is 13 squared and 144 is 12 squared. The square root of 160 does not have a perfect square. Well, yeah, you're right, but it can be simplified. 4 square root of 10. How about trying this one on your own? Two ways to do this. You could either start out with the square root of 60, or I would probably break it down. Okay, let's go 10. 10 breaks down into, like we said before, 5 times 2. Now, what does 6 break down to? Square root of 6. So that's going to be 2 times 3. Now, remember, if we have a square root times a square root, we could just, and it's only multiplication here, because you see the multiplication. Now, if it was addition, it'd have to be something different, but this only works for multiplication in between the two square roots. So, square root of 10, that's 5 times 2. Square root of 6, that's 2 times 3. We can put them underneath one radical sign, or one radical. And so now, if we're looking here, are there pairs? Well, yeah, the 2's, they have a pair, right? So it comes outside of the radical. And what's left inside? 5 times 3, right? Because they do not have pairs. The 5 and the 3 does not have a pair. And what is 5 times 3? Square root of 15, you got it. So, you could have went square root of 60, and then went from there, or just the way we did it. I feel like the way we did it, we worked with smaller numbers. Square root of 60, you got to try to figure out, does 4 go into it? Yeah, 4 goes into it. If you knew that quickly, 4 times 15 is the square root of 60, and then 2 square root of 15. It just depends on you. You know how to multiply quickly in your head. If so, maybe the one on the right is going to be helpful, but maybe the one on the left. Situational. Just practice and you get better at it. Let's try this one on your own. You go ahead and try this one on your own. Pause the video and you can hit play, and then I'm going to work it out fairly quickly. Square root of 15 becomes 5 times 3. Square root of 12 becomes 3 times 4. And I like 4 because it's a perfect square. I also like this pair right here of 3's that comes outside. And then 4, I mean, essentially 4 is just 2 times 2, right? And there's a pair there, and it comes out as 2. Or you could have thought the square root of 4 was 2. Either one, either way you think about it. What does not have a pair? 5 does not have a pair, so it stays underneath the radical. And finish. 3 times 2 is 6. Square root of 15 times square root of 12 is 6 times the square root of 5. You could have also done 15 times 12 is going to be 150 and 30. So the square root of 180. And then you would have reduced. Or not reduced, simplified. You would have simplified. All right, find the value of x. This is Pythagorean theorem. A squared, well, we know this is a leg and this is a leg, so the hypotenuse is going to be x. So we're going to say the square root of 3 squared plus the square root of 6 squared is equal to x squared. What's the square root of 3 times the square root of 3, or square root of 3 squared? Now, you can do it like this, which is the square root of 9, which then reduces to 3. Or you could just know the square root and squaring a number cancel each other out, leaving you with 3. And that's the concept that's going to be a lot easier, because once we start coming to problems that say, like, The square root of 45 squared. Well, you don't want to take 45 times 45 and then figure out whatever that big number is and the square root of it. Just realize square root and squaring a number cancel each other out, and that leaves you with 45. How about the square root of 6 squared? That was easy, wasn't it? 6. Square root and squaring a number cancel each other out. 3 plus 6 would be 9, and x squared is what 9 is equal to. How are we going to get x squared by itself? You take the square root, take the square root. X is equal to. Remember, when you take the square root of both sides, you get a plus or a minus. So the square root of 9, that's 3. But in this situation, we cannot have a negative 3 because we're talking about a distance. So in this situation, x is equal to 3. Positive 3, that is. The negative 3 is, it would work, and it would work, you know, when you plugged it in there, but when you talk about a situation that involves positive values, then you're good to go there. You have to only have positive 3 there. This next situation, I want you to try this one on your own. Pause the video, and when you're finished, hit play and check your solution with mine. The legs are going to be x and the square root of 18. The hypotenuse is the square root of 50. X squared, the square root of 18 times itself cancels out, leaving you with 18. And the same thing here with the square root of 50 squared leaves you with just 50. Subtract 18 from both sides. 50 minus 18 is going to leave us with 32. And then we have to take the square root of both sides to get x by itself. So therefore, x is equal to plus or minus, now the square root of 32. There's not a perfect square. 32 is not a perfect square. So let me do some work here. The square root of 32. I know what perfect square goes into 32, do you? 16. There we go. So it should be 4 square root of 2 here. And then what's x equal to? X is equal to positive 4 square root of 2. Hey. All right. That is not the end. I have a few others where we would like to rationalize the denominator. We want to rationalize the denominator. Now, there's some things that you don't want to happen in math. Like, you don't want 0 on the bottom of a fraction. That's bad, bad, bad news. And you don't want a square root symbol in the bottom of a fraction. So, how do you get rid of this? Simple. Multiply it by 1. Well, you're like, Mr. Bailey, that doesn't really change anything. It still gives us 3 over the square root of 2. Hey, yeah, you're right. That's good. Don't yell so loud at me next time. But we do want to multiply by 1. But we don't really want 1 to look like 1, like we have here. We want 1 to look like this number here. Isn't the square root of 2 divided by the square root of 2, isn't that 1? Hey, yeah. Yeah, it is. All right, good job. Well, the thing is, why would we multiply by the square root of 2 over the square root of 2? It's because, do you see the number on the bottom of this fraction, the square root of 2? You got it. When we multiply fractions, you multiply straight across. So that's going to be 3 times the square root of 2. And when you multiply here, on the very bottom, the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 becomes this, which becomes this, which then becomes this. But you should also recognize it as the square root of 2 squared. So when we have this on the bottom, We really just put a 2 there. The square root of 2 times the square root of 2 is equal to 2. And so this should be your final answer. Simplified form there. Okay. Let's try this one. Let's try 6 over the square root of 8. 6 over the square root of 8. Okay? Two ways to think about this. You know the square root of 8 will simplify. Let me show you both ways. Ideally, what you probably want to do, just to follow what happened right here, is multiply by the square root of 8 over the square root of 8. Okay, because when we're on the bottom here, square root of 8 times the square root of 8, that's equal to 8. And then we have 6 times the square root of 8 on top. What I was maybe suggesting was having 6 over, well, the square root of 8 then breaks down into, let's work that out. The square root of 8 is square root of 4 times the square root of 2, and the square root of 4 is 2. So that's what we have for the square root of 8. 2 square root of 2. And if we look, 6 over 2 will reduce to become 3 over the square root of 2. And so from here, I believe it's the problem at the very top of the screen. Multiply by the square root of 2 over the square root of 2, and that gives you that. And so this is where we're at. Well, let's look at these two problems up here. Right here. 6 times the square root of 8 divided by 8. Well, this is multiplication here. So you square root of 8 over 8, you know, these don't cancel out because the square root of 8 is not equal to 8. So you can't cancel those out and become 1. But what you can do is, since this is multiplication up here, how about we have like 6 over 8 times the square root of 8 over, let's say, 1. Yeah, that's just fraction multiplication right there. But 6 over 8 reduces to, what does 6 over 8 reduce to? 3 over 4. Square root of 8 stays on top. Well, you're looking there. Those are not the same. That's because of this right here. It's because you have to simplify the square root of 8. You have to simplify the square root of 8. Didn't we simplify the square root of 8 to become this right here? 2 square root of 2. So on top, we have 3. And then the square root of 8 becomes 2 square root of 2. Put a multiplication sign there. And on bottom, we have 4. I'm going to go ahead and reduce before we go any further. I know 2 goes into 2 once, and 2 goes into 4 twice. And so now we have 3 square root of 2 over 2. Which is that? You should always make sure that you simplify radicals. Whichever way you want to do it. You can do it the way we did it up in blue or the way we did it down in bottom in black. You practice these last two, and you can pause the video, work them out. You're just trying to rationalize the denominator. That's what it's called. You're trying to rationalize the denominator. So let's go 4 square root of 2 over top of the square root of 6. And then down here we're going to go 15 over top of square root of 3. You go ahead and try those out on your own. Pause the video, try them, and then hit play and watch my solution. Looking here, I want to multiply, once again, we're trying to get the denominator to be a rational number here. So the square root of 6 on top and bottom, multiply by 1. That's what we've done. So on the bottom, square root of 6 times the square root of 6 will give us 6, and on top, well, we know we have the 4. So what's the square root of 2 times the square root of 6? Square root of 12. The square root of 12 then, the square root of 12 I know is 4 times 3, which is the square root of 4 is 2, and that's the square root of 3. So really we have 4 times 2 times the square root of 3 on top, and 4 times 2 is 8, square root of 3. What number goes into 8 that also goes into 6? 2 does. 2 goes into 8 4 times, 2 goes into 6 3 times. And so we have rationalized the denominator there. 4 square root of 3 over top of 3. And here, on the bottom, we're going to multiply both the top and the bottom by the square root of 3 over the square root of 3. On the bottom, square root of 3 times the square root of 3 should leave you with 3. And on top, 15 times the square root of 3 is this. What number goes into 15 that also goes into 3? 3 does. 3 goes into 15 5 times, and 3 goes into 3 once. Now we don't need that 1 on the bottom. Actually, we need it there, we just don't need to write it. 5 times the square root of 3. We have rationalized that denominator. Hey, that's all we have for today. Thanks for stopping by, and we will see you on the next show.